All right, folks, buckle up, because today we are diving deep into the world of Terence Tao.
Terence Chi.
This guy is a mathematician.
Oh, he is brilliant.
So brilliant that he kind of makes the rest of us look like we're, just starting out with our ABCs.
He's really something else.
I mean, this guy's a certified genius.
Yeah, and what's amazing is it's not just the raw talent.
Oh.
He's got plenty of that, don't get me wrong, but it's how he combines that with this, insatiable curiosity.
Yeah.
He just wants to uncover the secrets of math, you know?
The elegance.
The elegance and the power of it all. That's what makes him so special.
So we're talking more than just a whiz kid here.
Oh, yeah.
And for this deep dive, we've got this pretty hefty biography from the McTutor History of Mathematics archive.
Okay.
And just reading through his childhood.
I know.
What makes the rest of us look like we were, napping through life.
Totally.
This guy was...
Well, think about it. At 2 years old.
2 years old.
He was teaching 5-year-olds how to spell and count.
Okay, wait.
Can you imagine?
2 years old.
2 years old.
I was barely forming sentences.
I know.
He's out there teaching 5-year-olds to spell.
It's incredible. And his parents, you gotta give him credit.
Oh, yeah. They saw it early.
They recognized right away that he was, not your average kid.
Yeah.
And they made the decision to pull him out of regular school.
It just wasn't the right fit.
Not at all. He was way ahead of the curve.
So wait, are we talking homeschooling situation or?
Well, it was a combination of things.
Okay.
They did homeschool him for a bit.
Right.
But they also found him tutors and mentors who could really challenge him.
So he was getting specialized instruction tailored to...
Absolutely. They knew he needed something more than what a typical classroom could offer.
So by 7 years old, this guy's cruising through calculus problems.
Yeah.
And understanding group theory.
Which is mind-blowing.
I'm still trying to wrap my head around basic algebra.
Right.
And he's over here tackling group theory at 7.
It's hard to even comprehend.
Okay, now this is where it gets really interesting.
Lay it on me.
So picture this 9-year-old Tao.
Okay.
Gets whisked off to Princeton's Institute for Advanced Study.
No way.
To meet some of the biggest names in mathematics.
Like math royalty.
The rock stars of the math world.
Wow.
I can't even imagine the pressure.
I know, right?
At 9 years old, to be in a room with these intellectual giants.
Must have been intimidating.
And one of these big names, Charles Pfefferman,
okay,
throws Tao this out of left field question.
What was it?
He says, imagine you're stuck in a room with a hungry lion.
A lion.
Yeah, like a real live lion.
Okay.
He says both you and the lion are represented as points in space.
So it's like a geometry problem.
Exactly.
Okay.
And Pfefferman continues. Now, let's say the lion can run faster than you.
Oh.
Or you can run faster than the lion.
Okay.
Or you both run at the same speed. How do you escape getting eaten?
That's a tough one, huh?
Right, it's not just a math problem. It's like a logic puzzle, a spatial reasoning challenge.
And he asked this to a 9-year-old.
A 9-year-old?
I wouldn't even know where to start.
I know.
And what did Tao do?
Well, we don't know exactly what his response was, but
Yeah.
the fact that he could even engage with a question like that
Right.
at that age,
Yeah.
it's just incredible. It shows his ability to think outside the box.
To apply mathematical reasoning to, real-world scenarios.
Yeah. Or in this case, lion-filled rooms.
Exactly.
But, it makes you wonder about the environment he grew up in.
Yeah. Was it something in the water?
He had 2 brothers, Trevor and Nigel.
Right. I've heard of them.
And they were also exceptionally gifted.
A whole family of geniuses.
Talk about a powerhouse family.
So what were his brothers up to?
Well, Trevor was an international chess master.
Wow.
He earned a double degree in math and music.
Impressive.
And he was also diagnosed with autism at a young age.
Really?
Yeah. And Nigel, he excelled in computer science, worked for places like Google.
Wow. So brilliance really ran in the family. It's amazing how it can manifest in so many different ways.
Right.
You've got the chess prodigy,
Yeah.
the tech genius,
Uh-huh.
and then you've got Terence, who's like this mathematical force of nature.
Exactly. So speaking of Terence, let's talk about his journey to becoming an Olympiad star.
Oh, yeah, the International Mathematical Olympiad.
This is where Tao really started to shine on the world stage.
That's the ultimate proving ground for young mathematicians. It's
Right.
like the Olympics of math.
Exactly. And Tao, he just dominated these competitions.
He did.
At 10 years old, he snagged a bronze medal.
Wow.
Then at 11, he got silver.
Okay.
And then boom, 13 years old, youngest ever gold medalist.
That's unbelievable.
It's insane, right?
It's not just talent at that point.
No.
It's dedication, it's training, it's that drive to push yourself beyond your limits.
It's like the combination of raw talent
Yeah.
and then this incredible work ethic.
Totally. And you know what's even more impressive is that he was doing all this while also juggling high school and university classes.
Wait, he was taking university classes at 13?
He started university full-time at 14.
13.
Yeah.
That just blows my mind.
And get this, by 15, he had already authored his first book.
His first book.
It was called Solving Mathematical Problems, A Personal Perspective.
So even at that young age, he was already sharing his insights with the world.
He was, and in that book, he describes his ideal solution to a problem.
How does he put it?
He says it should be relatively short, understandable, and hopefully have a touch of elegance. It should be fun to discover.
That's a great quote.
Right.
It's not just about finding any solution. It's about finding the most elegant and insightful one.
Exactly. And he talks about this aha moment he had where he realized the practical power of math.
What do you mean?
Like how math could be used to understand the world around him.
So it wasn't just this abstract thing.
No, he saw the connections to real life.
And that's what hooked him.
He says that moment hooked him for life.
I love that.
But, it wasn't all smooth sailing for him. Even geniuses hit bumps in the road.
Tell me more.
Well, during his undergrad years, he actually rebelled against a Fortran programming class.
Fortran?
Yeah, he preferred using BASIC.
Interesting.
And he ended up failing the class.
He failed?
He failed a class.
Even geniuses
Have
their rebellious phases.
Absolutely. It's reassuring, isn't it?
It makes him seem more human.
More relatable.
So he wasn't just this perfect machine.
No, he was a brilliant young man, but still a young man figuring things out.
It makes his achievements even more impressive knowing he had to overcome these challenges.
It shows that even the most exceptional minds don't follow a perfectly linear path.
Right.
There are detours, moments of, I'm going to do it my way.
Exactly, and that's okay.
It's all part of the journey.
So speaking of journeys, let's talk about his move to the U.S.
Ah, yes.
At the ripe old age of 16 to pursue graduate studies at Princeton.
Princeton.
One of the most prestigious universities in the world.
It's a big leap for anyone.
Especially at 16.
I mean, leaving your family and everything familiar behind.
Yeah, to go to a different country.
It's got to be tough.
And for Tao, he initially struggled to adjust.
To life away from home.
Yeah, and to develop those all-important study habits.
It's a lot to handle at that age.
It really is.
So how did he manage to not just survive, but thrive in such a demanding environment?
Right. What was his secret weapon?
Well, a lot of the credit goes to his advisor, Elias Stein.
Elias Stein.
A true giant in the world of mathematics.
Okay.
Now, Stein had this unique approach to guiding Tao's research.
I'm intrigued.
Instead of giving him specific problems to solve, he would introduce him to preprints. Those unpublished research papers.
Oh.
And he'd encourage Tao to explore the ideas and techniques within them.
So it's like giving him a map and compass.
Exactly.
Instead of step-by-step direction.
Precisely. He wanted Tao to develop his own path, to find his own way through the mathematical wilderness.
It must have fostered incredible independent thinking skills.
Oh, absolutely. It forced him to really engage with the material.
And to understand the research process from the ground up.
Exactly.
So it's like sink or swim.
In a way, yes.
But Tao, he clearly swam.
He more than swam. He thrived.
He did.
And amidst all this academic whirlwind, he also found time for, life.
Oh, yeah.
He met and married Laura, an electrical engineer who worked at NASA.
No way.
Yes, wait. Talk about a power couple.
They went on to have 2 children.
So he had a family life, too.
It's amazing how he managed to balance it all.
It is.
The demanding research, family life.
It's a testament to his dedication and time management skills.
So we've covered his childhood, his Olympiad victories, his university years, even a glimpse into his personal life.
Right.
But let's be real, we're all here for the Fields Medal.
The Nobel Prize of Mathematics.
Exactly. And in 2006... at just 31 years old, Tao received this prestigious award.
Recognizing his groundbreaking contributions to a whole bunch of different fields.
Yeah, we're talking partial differential equations,
combinatorics,
harmonic analysis,
additive number theory.
The list goes on and on.
He really made his mark.
So in the next part, we're going to dive into the specifics of his remarkable achievements.
Buckle up.
It's going to be a wild ride.
It is.
We're going to explore the frontiers of mathematical thought with Terence Tao as our guide.
I can't wait.
Stay tuned. Okay, so we've established that Terence Tao,
this guy,
he's a mathematical force of nature.
Oh, yeah.
But what I find truly remarkable is that he doesn't just, lock himself away in some ivory tower.
Right.
He actually takes the time to share his love for math with the world.
It does.
Through his writing.
You see, that's what sets him apart.
Yeah.
Many brilliant minds are content with solving problems, within the confines of academia. But Tao, he wants to spread the beauty and power of mathematics.
To the masses.
To everyone.
So where do we even begin with his writing? If someone like me, who's, mathematically challenged, wants to get a taste of Tao's brilliance, where should they start?
I'd say his first book is a great entry point.
Solving Mathematical Problems. A Personal Perspective.
That's the one.
The one he wrote when he was 15.
15 years old.
It's crazy.
That's unbelievable.
But isn't that more of a textbook?
It is a textbook, but it's not your typical dry and boring one.
Okay.
Tao, he writes, with this incredible clarity.
Yeah.
And he even sprinkles in personal anecdotes.
Oh, that's cool.
So you get a glimpse into his thought process.
Like that.
He emphasizes the importance of elegance and simplicity in mathematical solutions.
So he's trying to make math fun.
Exactly.
Not just some tedious chore.
He wants you to see the beauty in it.
Okay, but what if you're ready to level up?
Okay.
What's next on the Tao reading list?
Well, for those looking to delve a bit deeper, his 2-volume textbook analysis is considered a classic.
Analysis?
Yeah, it covers the foundations of real analysis.
Which is basically a rigorous exploration of calculus.
Right.
Oh boy, calculus.
Yeah. Brings back memories.
Not all of them good.
But I promise you this textbook is actually engaging.
Really?
It's known for its clarity, rigor, and well-chosen examples.
So it's not exactly like beach reading.
No, not exactly.
But it's considered a very accessible introduction to a subject that can be quite challenging.
That's the goal.
It's interesting. We often picture geniuses as these solitary figures.
Right.
Isolated in their own world of thought.
Yeah.
But Tao seems to be quite the opposite.
He does.
He's constantly reaching out, connecting with others.
Yeah.
Sharing his passion for math.
And you know what? He has a blog.
Wait, a blog?
The blog.
The Fields Medal winner has a blog.
He does, and it's not just some casual online diary.
Okay.
His blog is a goldmine of mathematical insights, explanations of cutting-edge research.
Wow.
Reflections on the nature of mathematics itself.
That's incredible. So even someone like me could go online and peek into the mind of this mathematical genius.
Absolutely. He's incredibly generous with his time and knowledge.
That's awesome.
He even uses his blog to answer questions from readers.
Wow.
And offer guidance to aspiring mathematicians.
That's dedication.
It is.
So we've got the beginner-friendly textbook, the more advanced one for those feeling brave.
Yeah.
And then the blog for anyone ready to take a deep dive into the world of mathematical thought.
Right.
What else is out there?
Well, he's also published several research monographs.
Research monographs?
These are books that delve deeply into specific areas of his research.
Okay, so those are for the hardcore math enthusiasts.
Pretty much, they're more specialized. But if you're fascinated by, say, nonlinear dispersive equations.
Nonlinear dispersive equations.
And you want to understand the nitty-gritty details of his work.
Yeah.
It's all there.
Okay, I think I'll stick to the blog for now.
That's fair.
But it's amazing that he makes his research so accessible.
Right. And it doesn't end there.
Oh, there's more.
He's also written articles for popular science magazines.
Like? Cool.
Wanta Scientific American.
Oh, right.
Explaining complex mathematical concepts to a broader audience.
So he's really trying to reach people.
He is. He wants to share his passion with the world.
I love that.
And to top it off, he's even taken some of his blog posts and compiled them into books.
So it's like a best of collection?
Kind of. It creates these fascinating hybrids that are part textbook, part research journal, and part personal reflection.
It's like getting a glimpse into his mind.
Exactly.
So it's not just about the formulas and theorems with Tao.
Oh.
It's about the journey.
The struggle.
The moments of inspiration that lead to those breakthroughs.
It makes him seem more human.
More relatable.
Exactly.
He's incredibly open about the dead ends he encounters.
It challenges.
It's a powerful reminder that even for a genius like Tao mathematics, isn't about effortless brilliance.
Well, it's about hard work.
Perseverance.
Embracing those moments of frustration as part of the learning process.
I love that.
It's inspiring.
It really demystifies the image of the lone genius.
Yeah.
Makes the whole process of discovery feel more human and attainable.
Exactly.
So what does this all mean for our listeners?
What do you mean?
Those who might not be mathematicians, but are clearly intrigued by the mind of a prodigy like Terence Tao.
I think it means that there's something for everyone in Tao's work.
Yeah.
Whether you're seeking a challenging textbook a glimpse into the world of mathematical genius, or simply a thought-provoking blog post.
Yeah, bound to find something that resonates with you.
I truly believe that.
And it goes beyond just the math, right?
It does.
It's about those larger lessons about learning, the importance of curiosity.
Embracing the unknown.
Recognizing the human element behind even the most brilliant minds.
Absolutely.
Terence Tao's work is a testament to the power of human curiosity.
It is.
And our capacity to understand the world around us.
And his willingness to share his journey makes it all more inspiring.
So we've covered his early life, his incredible achievements, his unique approach to problem solving, and his efforts to make mathematics accessible to a wider audience.
You've covered a lot of ground.
What's next on our Terence Tao adventure?
Well, in part 3, I think it's time to delve into some of the specific areas of his research.
Oh, yeah.
And try to grasp, at least conceptually, the groundbreaking contributions he's made.
From prime numbers to fluid dynamics.
The Kaya problem.
The Erdős discrepancy problem.
It sounds like a wild ride.
It does. But I think we're ready for it.
I think so, too.
After all, we've already witnessed the power of Tao's mind to tackle even the most challenging problems.
I have.
So buckle up, because we're about to explore the frontiers of mathematical thought.
Let's do it.
Okay, deep divers, we're back and ready to wrap up our Terence Tao expedition.
We've explored his life, his work, his philosophy.
But now
it's time to get our hands a little dirty.
Yeah, let's roll up our sleeves.
And grapple with some of his actual research.
Now, remember those prime numbers we talked about earlier?
The building blocks of all other numbers?
Right.
Well, Tao, along with his collaborator Ben Green, they proved this remarkable theorem about them.
The Green-Tao theorem.
That's the one.
You mentioned it revealed some hidden structure within prime numbers?
I did.
To refresh my memory, what was so groundbreaking about their discovery?
Well, they showed that prime numbers contain arithmetic progressions of any length.
Arithmetic progression?
Yeah, you know, like a sequence of numbers where each number is bigger than the last by a constant amount.
Like, give me an example.
Like 3, 7, 11, 15.
Okay.
That's an arithmetic progression with a common difference of 4.
Got it. So they found these patterns hidden within the prime numbers.
Exactly. It was a long-standing conjecture in number theory. A puzzle that had stumped mathematicians for ages.
And they cracked it.
They did. The Green-Tao theorem wasn't just checking a box.
Right.
It provided a whole new way to look at prime numbers.
So it's more than just a cool mathematical trick.
Yeah.
What are the implications of this theorem?
Well, understanding the structure of prime numbers is crucial in fields like cryptography.
Cryptography?
Which is all about secure communication. Think online banking secure messaging.
Right.
All those things we rely on to keep our information safe.
So this seemingly abstract mathematical concept actually impacts our daily lives.
It does.
That's pretty amazing.
It is, but prime numbers are just one piece of the puzzle.
Of course.
Tao has unlocked many other mathematical mysteries.
Okay, like what?
Well, his work on the Kaya problem is another great example.
The Kaya problem.
It's a geometric problem, and it might sound a bit strange at first. I'm intrigued.
Imagine you have a needle.
Okay.
And you want to rotate it 180 degrees within the smallest possible area.
I can vaguely picture that.
That's the essence of the Kaya problem.
But I imagine it gets pretty complicated.
It does, especially in higher dimensions.
The Kaya problem in higher dimensions has puzzled mathematicians for decades.
And Tao made progress on this.
Significant progress. His work has surprising connections to other areas of math.
Like what? Give us some examples.
Well, it turns out the Kaya problem is related to a branch of mathematics called harmonic analysis.
Harmonic analysis.
Remember how we talked about breaking down a sound into its individual notes?
Yeah.
Harmonic analysis does something similar, but with mathematical functions.
Okay.
And this has applications in all sorts of fields, from signal processing to understanding the behavior of light and sound waves.
So by tackling this geometric puzzle,
Tao inadvertently made discoveries that could impact our understanding of how we process sound.
Or even how light travels.
Exactly. It's fascinating how these seemingly unrelated areas of math are interconnected.
It really is, and that's one of the things that makes Tao so remarkable.
He sees those connections, those threads that weave together different branches of mathematics.
And he's not afraid to dive into the most abstract realms,
knowing that his findings might have ripple effects in unexpected areas.
So we've got prime numbers, geometric puzzles, and their connections to real-world phenomena.
What else could there be?
Right. What else is on Tao's mathematical hit list?
Well, his work on partial differential equations is another area where he's made groundbreaking contributions.
Partial differential equations?
These equations are like the workhorses of mathematical modeling.
Okay.
They describe how things change over time and space.
That sounds pretty broad.
It is, think about fluid flow, the spread of heat, the behavior of electromagnetic fields.
Right.
All of these can be modeled using partial differential equations.
So these equations are essential for understanding all sorts of physical phenomena.
Absolutely. And Tao has developed new techniques and insights that have deepened our understanding of these equations.
Especially in areas like
nonlinear dispersive equations and the famous Navier-Stokes equations.
the Navier-Stokes equations.
Those are one of the Clay Mathematics Institute's Millennium Problems.
Each carrying $1 million prize for a solution.
That's right. These equations describe fluid motion.
Right.
Think water flowing through a pipe, air moving over an airplane wing, even the flow of blood in our veins.
Wow. So important stuff.
They are notoriously difficult to fully understand and solve.
And Tao's working on this.
He hasn't cracked the entire problem, but his contributions have significantly advanced the field.
So he's potentially on track to win another $1 million.
Maybe. But even beyond the big-name problems, Tao has this uncanny ability to find connections between seemingly disparate areas of mathematics.
You mean like he can see how different areas of math relate to each other?
Exactly. He's made significant contributions to fields like compressed sensing.
Compressed sensing.
Which has revolutionized how we acquire and process data.
Okay.
Random matrix theory, which has applications in everything from physics to finance.
Wow.
And he even solved the Urges discrepancy problem.
The Urges discrepancy problem.
A puzzle that had baffled mathematicians for decades.
Remind me what that was about.
It deals with sequences of plus and minus ones.
Plus and minus ones.
Imagine you flip a coin an infinite number of times.
Right.
And record the results as +1 for heads and -1 for tails.
Got it.
The Urges discrepancy problem asks, can you always find a pattern in this seemingly random sequence where the sum of a certain section of the sequence deviates significantly from 0?
That sounds complicated.
It is Urges himself, one of the most prolific mathematicians of the 20th century,
Now,
posed this problem back in the 1930s.
and Tao solved it.
It speaks to his deep understanding of mathematical structures.
And his ability to find order within chaos.
Exactly.
So we've covered prime numbers, geometric puzzles, partial differential equations.
Even sequences of plus and minus ones.
It's clear that Terence Tao's impact on mathematics is vast and far-reaching.
It really is.
So as we wrap up this deep dive,
What's
the key takeaway for our listeners? What's the lasting legacy of Terence Tao?
I think it's this. His story reminds us that even geniuses aren't born knowing everything.
They have to learn. They struggled. They pushed themselves.
Exactly. It's about the journey, not just the destination.
The constant pursuit of knowledge.
The willingness to explore the unknown.
And the understanding that even the most complex ideas can be broken down and grasped.
Terence Tao's work embodies the spirit of mathematical discovery.
And the power of the human mind to unravel the mysteries of the universe.
So keep those minds curious and keep exploring.
And on that note, we'll wrap up this deep dive into the fascinating world of Terence Tao.
A true mathematical prodigy.
Thanks for joining us.
It's been a pleasure.